Today I want to talk with you about the idea of running HPC anywhere. And certainly many of us in this business have been doing HPC for a long time and supercomputing, focused on really driving next generation performance, capability machines. We're in the exascale era, and it's an exciting time to be in HPC. But one of the other important things for industry is the agility needed with HPC and the desire to run this not just in large monolithic machines, but also in machines in many different geographies, and certainly HPC in the cloud, which Nimbix has been doing for nearly a decade. So I think today I want to focus our agenda on a few things. First, I want to introduce you, if you're not already familiar with some of our offerings and products. I'm going to talk specifically about some of our technology, and then most importantly, the benefits of why HPC Anywhere is important and relevant for us as we think about blending the best in breed of capability and exascale machines with opportunities for agility for HPC in the cloud. First, a couple of words about Atos and Nimbix's global leadership in HPC in both on-premise capabilities and also cloud and any cloud, and thus really driving the theme of HPC Anywhere. Obviously, many of you have known the Atos brand around the capability of supercomputers and AI and quantum leadership, and this is continuing as we talk, and some of my colleagues talk about some of the great leaps in performance that we're making as a business. But also as we take the cloud component of this into the next generation and make it extremely easy for our customers, industry, academia, public sector to really be able to have agility with their HPC workflows and actually be able to port those from one cloud to another or to many different on-prem systems. And certainly, this is a trend that we're seeing from the analysts in the community, with obviously huge movement of workloads into the cloud as the public cloud infrastructure providers have begun investing in more and more capability within their platforms, faster interconnects, new kinds of heterogeneity of architectures, and so therefore they become more viable for HPC workloads. And this is an area that Nimbix in our journey have pioneered with the modernization of HPC in containerization, and I'm going to talk about some of that technology here today. Let me start with our key offerings within the Atos portfolio. And many of you that may be familiar with the Nimbix brand may know the Nimbix Cloud, which is one of the first clouds to really focus on accelerated computing, bringing FPGAs, GPUs, AI semiconductors, lots of fast fabric and true supercomputing to the cloud. And an offering that we call Nimbix Cloud Everywhere, our Nimbix Cloud service with HPC on demand on a pay-per-use basis. And so obviously this platform is a service we provided for many, many years, running hundreds of millions of workloads. That's point and click software as a service with all the main use cases of HPC and simulation in various domains in AI and deep learning, et cetera. And this can be delivered on various types of infrastructure, including all of the major public cloud providers around the world. So this is for organizations that have engineers, researchers, developers who need click to run HPC, the highest levels of agility, don't maybe have the appetite to learn the different mechanics of various cloud providers onboarding into infrastructure that want point and click HPC. This is an opportunity to get started in minutes and be able to scale very rapidly in terms of compute capacity. Moving to the right, we have the technology that Nimbix has developed over many years that is now available as a software platform and product called Jarvis XE, along with the HPC App Store HyperHub. This is offered as an annual license. It's installable anywhere on a public cloud, on-prem supercomputers, of all types, of all different types of infrastructure capability as well. And this is the leading container native hybrid multi-cloud HPC platform. It enables a true container native approach to HPC, even for non-traditional, non-container based applications, such as leading simulation OEMs and, like Ansys and Siemens and Dassault, et cetera. And this is for organizations that wish to still blend the best of breed of on-prem with also beginning to adapt their workflows into cloud with a seamless experience for their HPC admins and users and IT infrastructure owners. It gives full control and overall cloud-like platform control to the organization. And then finally, we have a component add-on to Jarvis XE, which is the control plane for the platform and HPC scheduling and application management, called Cloud Pak, that actually extends the capability of any on-prem machine or any cloud-based HPC clusters to any other downstream HPC cluster. So this could scale from a cloud to on-prem, or from on-prem to cloud, or multiple variants of that, including multiple endpoints around the world. And this is really important for organizations that have globally distributed teams that may have latency requirements for data movement, interactivity, and they wish to keep that compute close to the end users. And this is a technology and the platform and offering that enables that. So I'm going to talk a little bit more about Jarvis XE and HyperHub, and then I'm going to dive into a little bit more depth around the technology behind it. And then we'll conclude with some of the benefits there. But Jarvis XE is the platform for organizations who wish to consume HPC in a public cloud, a private cloud, or private infrastructure, or some hybrid variant of those two. And the goal here is to create not just a web portal that links you to all these things and simplify the user experience, but enable the customization of those workflows and allow those to seamlessly synchronize to all the global compute endpoints around the world. This obviously also simplifies infrastructure management for HPC admins, as well as the enterprise IT teams who may be required to typically manage the infrastructure for an organization. And this unifies the capability for both not just traditional HPC, but also for advanced data science applications and AI, deep learning, and analytics under a single platform. Importantly, it's a modern and containerized application distribution platform, not just for click-to-run apps, but it is an open platform for enabling developers and custom algorithm owners to deploy those codes in a containerized fashion. And that platform capability, called push to compute, is available in Jarvis XE. And so for those not familiar or have not already Dockerized or containerized workflows, this platform provides the mechanisms to do that. And that includes for very advanced, highly parallel MPI-based applications and scaling those across large-scale environments on all different types of fabrics. The other benefit associated with the containerized application distribution is the fact that it can be automatically and globally synchronized to all compute endpoints, all cloud endpoints in a given infrastructure landscape. And ultimately what this does is it reduces complexity for the customers, and it unifies their environments and the workflows for all of their end users. And ultimately, this is about lowering costs and increasing productivity. At the end of the day, what we're here to do is drive innovation and allow domain scientists to be domain scientists to be able to get their work and their answers faster and at the lowest possible cost. So with Jarvis XE comes the benefit of the synchronized application marketplace that we call HyperHub. We call this HyperHub because this marketplace includes applications of any type of hardware capability, whether it's GPU accelerated applications, FPGA accelerated applications, other types of CPU architectures, ARM, Power, x86, fabrics on Ethernet, InfiniBand, and various low latency interconnects. And so because this application marketplace transcends any one vendor technology, it's a very open platform for users to take advantage and curate and deploy their own codes based on their architecture of choice. It enables the seamless deployment and curation in a continuous integration and continuous deployment manner, so that your developers and the owners of the code can actually be working consistently on that code, pushing it, and it automatically propagates globally across the infrastructure and clouds so that the end users can consume that in a completely seamless fashion. And certainly it delivers these applications as point and click workflows, regardless of the location or type of infrastructure it's loaded on. So it's a very important capability of the platform that delivers much more value than just a simple front end to cloud-based resources or on-prem based resources. The Atos Nimbix portfolio has experience and significantly broad industry support across the public sector, academia, obviously all of the major traditional HPC industries, including aerospace, energy, life sciences, importantly, in simulation manufacturing, and then of course in the fields of data science, and even HPC and in the product domain, in retail and media. Obviously, the HyperHub marketplace has applications ready to run and tailor-made for these industries out of the box, but it's also a platform that can have all of an organization's custom applications curated and deployed seamlessly. We also support various licensing models, and this is important for customers who spend lots of money each year on their important ISV licenses to do their science or their domain engineering. And Jarvis and the platform works in concert with each of these vendors, supporting those various licensing models in a bring your own license model, but also has built-in licensing support for ISVs who wish to also curate their applications in the HyperHub marketplace. So now I want to shift and click down a little bit deeper into the architecture and the technology behind the idea of doing HPC Anywhere. And ultimately, when I say anywhere, it's this idea of deploying, whether it's on-prem or also in any cloud endpoint around the world, and hybridizing between these. And at a very high level, there's a concept that we've introduced called an upstream and downstream HPC clusters. And in the upstream zone, this is where the single pane of glass for the control plane, the application sort of hub and centricity for authentication, single sign-on, your actual landscaping of the global environment is handled in this control plane. It is the source of the Jarvis processing API. This is the web API for job submission and job management across this hybrid platform, and also is the source for application management and synchronization. The second component is around downstream clusters, and these are simply federated compute and storage zones or clusters that are federated amongst each other. And this is enabled by that product I showed earlier called Cloud Pak, and having virtually unlimited versions of these Cloud Paks out in different zones or regions of your preferred cloud provider or of multiple cloud providers without sacrificing the same interface, the same application bits, and the same components that your end users see regardless of where they run. So this is deployed on any Kubernetes compatible infrastructure. To enable that supported and converged federation, there's almost no management for the downstream environments. And in fact, it plugs and plays with every major cloud provider's Kubernetes endpoint, including all of the HPC class resources they avail in those Kubernetes endpoints. But it can also be deployed on any other remote Kubernetes infrastructure. Unique capabilities like integration with Red Hat OpenShift, with VMware Tanzu, these that have Kubernetes-based deployments and multi-cloud capabilities that the Jarvis platform simply lays on top of and enables the synchronization of the HPC and AI workflows. Another key component of the technology is the Jarvis's inherent capabilities and convergence with Kubernetes. And this is important because Kubernetes is pervasive across the IT industry, originally developed by Google for scaling web services. And Nimbix has really pioneered the use of Kubernetes, making it truly an HPC class environment for scaling HPC anywhere. As we all know, with traditional HPC schedulers, these were originally designed to support machines that are inside of four walls and maximizing the number of jobs that can be packed onto a machine or a cluster of machines at a given location. Obviously, those are being adapted to be able to burst into different clouds. However, our view is that in modern HPC Anywhere scheduling, let's embrace technology that's ubiquitous and give it the HPC attributes and the supercomputing attributes that are needed in our traditional sense. And so with the Jarvis XC platform, we include and package in our own advanced schedulers. This can be integrated to work with traditional HPC schedulers, but it is also a standalone enterprise-grade HPC scheduling platform that's fully container native in a hybrid mechanism. And so there's a lot of different capabilities. If you do have interest in digging deeper in some of what this can bring your organization, we definitely would encourage you to reach out after this presentation. So I want to summarize a few of the key elements for Jarvis XC for these anywhere HPC workflows. And there's really 4 elements that are really important, right? The first, obviously, is the user interface, API, and the control plane. You want to support authentication, secure authentication within your traditional enterprise authentication and identity management systems. The platform integrates seamlessly with those identity management systems to create a single sign-on platform that scales across the organization globally. You also want your users to have full self-service capabilities, regardless of whether they're running on-prem or in the cloud, and the ability to manage that in a self-service fashion from the administrator side as well. The second component is the ability to create and deliver a scale-out HPC and AI scheduling technology that is truly hybrid and multi-cloud by design, including best fit algorithms with customizable policies for resource weighting, very similar to what's been done in traditional HPC scheduling technologies, but also including all the advanced autoscalers with the respective clouds so that you can maintain the lowest possible spend for your cloud endpoints. The other really important factor with these advanced scheduling capabilities is license-based queuing, the ability to truly maximize all of your ISV licenses, regardless of where your compute lives. That makes it easy for license managers and software asset managers to maximize your licensing usage, but also not create a poor user experience for engineers and scientists who may be wanting to consume those licenses and having jobs fail just because it's being run in a zone that may not have access to the licenses. So elements like that are truly important as you start thinking about global hybrid anywhere deployments. Finally, the last 2 points, easy deployment automation. We wanted to make it extremely easy to deploy this, bring it up, and be able to click to run in minutes. We have some code that I'd invite you to check out the GitHub link for the Jarvis Helm documentation and make this extremely easy for HPC admins and IT admins. And then finally, as I talked about the application marketplace, the world of HPC revolves around applications and algorithms that need to run on infrastructure. So making this portable across any environment is obviously a de facto requirement for anywhere workflows to enable HPC anywhere. So I want to talk about some of the benefits in blending the best of on-prem and cloud as indicated at the beginning of the presentation with the some of the analyst comments about cloud doesn't necessarily mean that on-prem goes away. We still have critical workflows that need capability machines in the exascale era, but also being able to augment them. But being able to tune the on-prem systems to maximize their utilization 24/7 without fear of queuing, because you can burst and overflow into other compute zones and resources that are seamlessly and elastically available. So the platform gives total flexibility for burst strategy with instant public cloud support, irrespective of the provider of your choice. Certainly, Nimbix has our own service that we can offer in conjunction with the various public cloud providers, but we ultimately provide customer choice and can even run in customer tenancies just based on on your own preference. The other important benefit is the ability to have seamless and universal job management and accounting metrics across machines, clusters, zones, users, applications, and all variants thereof to be able to assess the economics of your computing environment. This is really important and increasingly important as we work to improve on both the capability, the time to results, and ultimately the cost of those results. I think we all understand that we can spend millions of dollars to speed up getting an answer, but sometimes we need to speed up getting an answer without spending millions of dollars. We need to find the best, most cost-effective ways to do that. And another key benefit is enabling customers to test and access new hardware as it becomes available and online in an extremely efficient and easy way, which is something Nimbix has been working aggressively on for over a decade. We have many customer successes and white papers for your consumption and review. I would invite you to visit us at atos.net or nimbix.net for easy access to these resources. We also have a number of links to publicly available documentation. I would invite you to review the documentation in a technical white paper with HPC on Kubernetes, and also to visit our Jarvis repositories and API references. And if you do have interest in actually getting your hands on this technology, we invite you to reach out following this presentation so that we can actually get you access to Cloud Paks, to Jarvis XE to be able to deploy anywhere you would choose to deploy it. And with that, I'll conclude. My contact information is here for your review. I really appreciate your time and attention, and thank you, and hope you have a great SC. Thank you.